0.6 grams of an unknown hydroxide was dissolved in water, and the solution was made up to 250 centimeter cube in a volumetric flask. In a titration, 25 centimeter cube of the solution of hydroxide required 21.2 centimeter cube of 0.25 mole decimeter cube per decimeter cube HCl to reach the end point. That's the concentration of the HCl, and that's the volume of HCl. We know the volume of the base. We're given the equation. Now we need to identify the unknown hydroxide, which is XOH subscript 2. So it might be best to write down the equation again, which is 2HCl plus XOH subscript 2, and that gives XCl2 plus 2H2O. Now, what we now need to do is to look at the base hydroxide, which is XOH subscript 2, and that can split into X2 plus OH minus, and there's two of those, and that implies that X2 plus is a group 2 metal. So we now know where the X is coming from. It's group 2. At the same time, let's work out the ratio, stoichiometric ratio. This is 2 to 1 to 1 to 2. And we can also work out the concentration. C is given for the acid is 0.25 molar. Molar means mole per decimeter cube. And we know the volume is given, and the volume is for the acid is 21.2 times 10 to the power minus 3. That means you're dividing it by 1,000, and because I'm converting the centimeter cube here to decimeter cube, just to know about conversion rate, and to convert, if you have 10 centimeter, that gives 1 decimeter, sorry. And if I cube it like that, then I have to cube that, and that implies that this is 10 to the power 3 centimeter cube will be 1 to the power 3 decimeter cube, and that's basically 1,000 centimeter cube gives 1 decimeter cube. So that's why we divide by 1,000 or multiply by 1,000 if we're converting between centimeter cube to decimeter cube. And so now we know we can work out the mole for the acid, and the mole for the acid will be the volume times the concentration. So in that case, when we multiply the two together, we get 0, just write it here, so we get 0.00 0.0053. So that's the mole. And because it's ratio 2 to 1 here, so if this is 0.0053, I need to divide that mole by 2 to get the mole for this one, because it's 2 to 1. Hence, I can get the mole for that one to be 0.0053 divided by 2, and that gives 0.00265. And that's the mole for the base. And the volume for the base, we know we've used 25 centimeter cube, and if we can convert that to decimeter cube, it will be 25 times 10 to the power minus 3. That meant it's been divided by 1,000. Okay, so now the mole for the mass. So we've used 1.96 grams, and then we've taken 25 centimeter cube from there. So that mole corresponds to 25 centimeter cube, that volume. So now we need to map that volume up to 250, which then corresponds to that mass. So what we need to do now is to say, well, 25 centimeter cube gives basically the mole we got here, which is 0.00265 moles. 1 mole with 1 centimeter cube, so that means I've divided 25 by 25 to get 1, will then give 0.0025265 divided by 25. Okay, so that's what we've done. Now I need to then multiply 1 decimeter, that's 1 centimeter cube. I need to multiply that to 250 centimeter cube. So if I multiply 1 by 250, I have to multiply the right hand side by 250 as well. So now I get 250 centimeter cube will now give, well, 0.00265 divided by 25 times 250. Well, as you can see, 25 counts to 25, you get 1 there, so that's 10. And therefore, the 250 centimeter cube will give, so the 250 centimeter cube will give 0.02, well, let's say 0.265 times 10, and that gives 0.0265 moles. So that's 250 centimeter cube gives 0.0265 mole. Now that we know that mole corresponds to 1.96 grams. So we now know, we also know that mole is equal to mass over relative molecular mass, and we want to find the relative molecular mass, and that implies that relative molecular mass, will be mass over mole. And that means that the relative molecular mass in this case will be the mass, which is 1.96 divided by the mole, which is now 0.0265. And that gives, if I divide that together, that gives me 73.96 grams per mole. That's per mole, 73.96 grams per mole. Now we got 73.96 grams per mole gives the mass for the XOH subscript 2. And that implies that X plus 2 OH masses is equal to 73.96. Well, to find the X, all I need to do is X will be equal to, well, I just need to take the 2 OHs and take it to the other side. So I'm going to get 73.96 minus 2 OH in terms of their masses. So that would be 73.96 minus 2 times, well, oxygen is 16 and H is 1, so that's 17. And that'd be 73.96 minus 34, get 39.96. So that'll be 39.96 grams per mole. So that's the X. Now if I look in the periodic table, I know that's group 2. So we saw that that was group 2. So group 2 element. And if you look at the relative molecular mass of any element in group 2, that X happens to be calcium. So X is calcium. It's a metal that has a relative molecular mass, element that has relative atomic mass of 40, roughly 40 grams per mole. And so therefore, the compound we're looking at, calcium OH subscript 2. So that's what the base is.